so this is what we're making today. It's a 3D multiplayer game. It just runs over LAN right now, but you can set up dedicated servers. You could do port forwarding if you want to. I'm not going to go over that in this tutorial, but that's definitely an option. And you don't really have to change much of my code if you want to do that. Right now, we're just going over the basics of like multiplayer and applying it to 3D. So we're not really going to get in depth on mechanics. It's just going to be mainly just movement and spawning players in, but you definitely can add extra things after if you want to. So before we get into it, let's hear a word from our sponsor. You know, multiplayer stuff's kind of hard. If you don't want to deal with like paying for servers and like setting up all this random garbage that is networking, maybe you should try out Core, the sponsor of today's video. With Core, you don't have to worry about the network backend. It's going to do it all for you, and you don't have to worry about paying for server hosting because it does all that for you as well. Core is a new gaming platform where anyone can create, share, and play PC multiplayer games. Core is completely free, so you can host servers for free, you can play games for free, you can make games for free, which is, you know, kind of cool. No coding is required, so if you're new to game development, this is a great way to start making games. Thousands of free music, sound, and art assets are bundled in with Core. You can make your own scripts, you can make your own 3D models, and you can remix content shared by other creators. If you're looking to make something more advanced, Core offers that as well. You can program game logic in Lua. Core is powered by Unreal Engine, so the possibilities are endless. With that, you're gonna get high quality AAA graphics right out of the box. You can make multiplayer games faster than ever with Core. If you're worried about making money off games, Core can help you there too. Core offers 50% revenue share with its game creators through the Core Perks program. That's 2 times Roblox revenue share and 10 times Fortnite Creative's revenue share. Core creators have been able to pay their bills, buy their dream cars, and quit their day jobs with the help of the Core Perks program. In my experience, I found Core incredibly easy to use while still having all the tools that you would need for complex projects. If you want to start making multiplayer games, Core is an awesome platform to use for that. Use the link in the description to download Core for free and to start making your own game. So let's get into how we do this. This character right here, this model, Kenny's made it, Animate Characters 1. You can go download it here if you want it. Default format, FBX, doesn't really work well with Godot, so I converted it to GLTF in Blender. You can do so if you want, and then convert it to an inherited scene.tscn right here. That's essentially all I have here for this project. Now we're going to make a network script. We're going to set up a few constants. We're going to set the default port. You might want to make sure that port doesn't get blocked by another application. I'm just using 289.60. The max amount of clients. I'm going to set up a server and client variable. Both are going to equal null, but they're going to be set to multiplayer enets shortly. And the IP address that we're going to use. By default, we're going to go over localhost, which is 127.0.0.1. If you want to connect to another computer on your network, what you do is you go to control panel, you'd say ipconfig, and you look for your IPv4 address, and you put your IPv4 in of that computer that you're wanting to join that's hosting the game. We're going to make a few functions now. We're going to make a create server function. Now what this is going to do is it's going to print creating server. We're going to set the server equal to network multiplayer enet.new. That's going to create a new network multiplayer enet class that we can create the server from. We're going to do server.create server under our default port, which is this, under our max clients, which we defined up there. And we're going to get tree.set network peer to the server. So what this does right here is this grabs, remember the server is the network multiplayer enet that we assigned right here and made the new one of, and assign that to the variable. So what we mean when we set the scene tree to the network peer is we're saying, hey, this entire scene tree, we're going to put you under whatever ID this network multiplayer enet is. So then when I am checking if I'm the current player or if anything is belonging to my computer, the person that's hosting, I can check that by using this get tree, using the network peer on the tree. And this just essentially assigns it in the server. If we never assign it, we can never really send remote procedure calls. We can never really communicate between computers, which is exactly what we want in the multiplayer system. So we want to make sure we assign it our network multiplayer enet. Now join server. Yeah, so we're just going to be printing join server. That's pretty good. Essentially, we do the same thing we do up here with the network multiplayer enet. We assign that to the client and we create the client under our IP address, which is assigned here, which we will later allow the user to change if they want to, and the default port. And we still assign that to the network peer, our client. Now up here, we're going to assign a few signals. So get tree.connect, connected to server, server disconnect, and connection failed. You want to make sure you at least name these the same as the functions that we're going to set up here. That way they're actually connected. All of these are for debug purposes. They actually don't need to be in here, but we're just going to throw them in here just in case, just to make sure that your whole system is working. So function underscore connected to server, you can see this matches this one right here, which is the connected to server that we connected from the scene tree. It just says successfully connected to server, again, debug purposes. Same with server disconnected, and same with connection failed. Basically, we print all the stuff that's basically happening with the server setup, and then our final function in the script will be reset network connection. Now it says if get tree.has network peer. So you remember how we assigned the network peer up here. If we still have one assigned to our scene tree, then we'll set get tree.network peer equal to null. Now why do we check this before we set it to null? Well, sometimes we might have no network peer and it's already equal to null because we already reset the connection, and we don't want to set it back to null if it was already null previously. I'm pretty sure that will throw out an error in Godot, so we just want to make sure that we have a network peer before we try to reset it. Now we're going to use this reset network connection. We're actually going to use it up here under server disconnected. So reset network connection, and connection failed. We want to reset it because we want to redirect the player back to the server setup screen. So if there's an error ever connecting to the server, they could still reset up the whole server system. That's our network code. That's basically handles all the server and joining setup. Then what we're going to do is we're going to go project settings, auto load, and we're going to auto load our network.gd, and we're just going to add it as network. And what this does is now we don't need to have a direct reference to it. It basically everything can access it, which is really nice. So now we're going to go back to our 3D view. We don't need our character yet, so we can close out of that. We're going to make a new 3D scene. And this scene is just going to be our map. I'm just going to call it map. You can call it whatever you want. And in this scene, this will contain like all of our 3D assets, but I also want to make the network setup screen in the same screen. It just keeps everything simple for us. So we're going to add a new child node. It's going to be a control node. So this is going to be for our UI. We're just going to set the layout to full rectangle, and we're going to call this control node network setup. Then under network setup, we're going to set up a VBox container, and I'm going to set the size to 350 by 180, and then we're going to set layout center. So this VBox container is going to contain a few items that will sort them correctly to how we want it. The first item will be a line edit, the second item will be a button, and the third item will be another button. In this line edit, we're going to rename this to IP address. I'm going to set the alignment of this IP address to center, and we're going to set the placeholder text under this to IP address, which essentially is just going to tell the user, hey, you can insert an IP address here, and this placeholder text will change once they actually start typing it. Now for our buttons, you can see that they're really squished right now, and we want more room on those buttons. So what we're going to do is we're going to set the minimum size on the y-axis to be 60. And we're going to repeat this for both of the buttons. Minimum size 60. I'm going to rename the first button to host and the second button to join. Now, if you're going for a dedicated server approach, you wouldn't want to set up a host and join button because the server is always going to be hosting. So instead, you'd always have the server or the network always host in that version of the game, and then the players, the clients, will always be joining the server. And you could give the clients the option to use an IP address, or you can use a server that stores all the possible addresses of other servers if you're going to do something like that. In our host button, I'm going to set the text to host, and in our join button, we're going to set our text to join. And that's basically it. Very simple UI. That's all we really need. We're going to make a script on our network setup, so make sure you have network setup selected. We're going to select the script, and we're just going to call it network setup.gd. Hit create, and after I clear all this code, I'm going to press Control S, and I'm going to save my entire scene tree as map.tscn. I'll just save that there. Going back to our 2D scene, we actually want to connect our IP address text changed back to our network setup script right here. Just press connect there, and we're going to go to our host button, and we're going to connect the pressed signal back to network setup. Same with join, pressed, network setup. So that's all of our signals for all of our buttons. When the host button is pressed, we're going to call network.create server. Now remember how we auto-loaded network? That means anything can access it. So this is why we're able to say network.create server right here. Then we're going to hide, because remember, we're in the network setup. So when we toggle hide right here, what this is going to do is this entire visibility is going to go off. And what that's going to do is that's going to take us back to the 3D scene, so then we can play the game. Same with join. We're going to say network.join server. We're going to say hide. Then on text change, what we want to do is we're going to say network.IP address equals new text. So essentially, whenever we update this IP address text, it's going to be updated here. I'm just going to press run, and you can see I can't really make multiple instances of this window to test. You can see it's just going to refresh it. There is an add-on that will run multiple game windows when you're trying to do multiplayer. I don't have that because I'm not very fancy right now, but I'm just going to run it the old school way. And essentially, you just want to run a new instance of Godot, and then you could just press run on your project that you have selected. That is your project. I don't need to put an IP address because I already assigned it as 127.0.0.1, which is essentially localhost, so it will just loop back through on this computer. I can press host, and I can press join. And you can see that it said creating server, so we did make the server, but nothing happened. It never said anyone joined, and that's because we never actually set that up. So I'm just going to close these two, and we're going to connect one more just for debug purposes. And this is going to be network peer connected. And we're going to connect that to self, and I'm just going to call it player connected. And now all the way down here, I could just say function player connected. We have to pass in an ID. An ID is essentially when a player connects, they're always going to return their ID, and so we want to make sure there's an ID in this function. And then I can essentially just print that the player is connected with their ID. We should probably string that, and there you go. So we can test that now. Host and join, and it says player connected in their ID right here. So that means it is working. And we can close and we can close. So sweet, we have our multiplayer system basically working. Now that we have the multiplayer system in, we actually have to get the gameplay into the game because we can send data right now, but we want to have a game to show off. So what we're going to do here in our map scene, I'm going to add a new static body, and I'm just going to rename the static body to floor. In this static body, we're going to set up a new CSG mesh, which will be the floor. So for our mesh, I'm just going to make a new plane mesh, and then I'll crank up the size to like 50/50. Now we got our floor in, which is pretty good, but we need a collision shape on this because it's a static mesh and it's going to be colliding with our player. So we're going to add a new collision shape. This collision shape is just going to be a box shape, and we're going to set the extents to 25 on the X, 25 on the Z, and then I'm just going to move it down because it's kind of hovering above our plane. So I'm just going to move it down a bit, and you could just eyeball it. It doesn't matter if it's perfect, and that looks good. So we got our collision shape and our floor in, and this isn't needed, but I like things to look nice, so I'm going to add a directional light. Usually I want light in my scene. I'm just going to move it up. The position doesn't matter. It's just the rotation that matters here. For the rotation degrees on this directional light, I'm just going to set the rotation to -60 on the Y. That's really what I found looks good, and I'm going to save that. So that's our map. You know, we still need a player, so let's start working on the player. We're going to add a new scene, and this is going to be a kinematic body, and we're going to rename this kinematic body to player. Now we've already made our character. If you don't have a character, you could just make a CSG mesh and just use a capsule. We're actually going to instance our character.tscn under our player. I'm going to add a collision shape because this is a kinematic body, needs a collision shape so it can collide with the ground, and the shape is going to be a capsule shape, and we're going to rotate this capsule shape 90 degrees on the X. I'm going to move it into the center of the player, and then I'm going to set the height of this capsule to 2, and then you can see it fits around the player pretty well. And now I'm going to make a spatial node, essentially just contains vector 3 coordinates, and I'm going to move it all the way up to the head on the player. I'm just using control to snap, and I'm just going to snap it all the way to the head. And now it's in the general location of the head. We're going to rename this to head, and we're going to add a child node to this. It's going to be a camera, and you can see our player is not facing our camera. So what we're going to do is we're going to go in our player, we're going to set the transform, and I'm going to set the rotation on the Y axis to 180 degrees. Now you can see the camera is actually going out of their face, which is what we want. Now we can save this, and we just save it as player. That's fine. And now we have a player in our scene. Now we're going to add a script to our player, and essentially we're going to remake a FPS player controller. If you've done FPS games before, you're going to notice a lot of this code is going to be the same. But before we get to the code, we actually need to set up the input. So go to project settings, go to input map, and we're going to set up move forward action, move backward, move left, and move right. And we also want jump because that's fun. Okay, so move forward, I'm going to set that as D. Wait, no, what am I thinking? Move forward is W, not D. Move backward is S, move left A, move right is D, and jump going to be spacebar. Okay, now we have all of our inputs set up. We can close that. Let's set up a few variables. We'll set gravity to -40. Then we'll set speed to 16. We'll set jump speed to 15. We're going to set our mouse sensitivity to 0.08. Velocity is just going to equal a vector 3. And we're going to get the path to our head. So we're going to do export node path on ready var head equals get node head as spatial. Now, essentially, we are exporting a node path, and essentially in the same line of code, we're able to assign, since it's a node path, it's a string, we're able to use get node of the string of this node path since it's on ready back to itself. So essentially, it's just going to return the node of what we assign. As spatial essentially tells it, hey, this node needs to be a spatial type node. It won't work with any other node. So we can go back to our player. We can set our head, and it's going to say assign node. So I can click assign node, and I can assign it our head node 3D. I can press OK, and now we're getting a reference to our head. Under the ready function, we're going to set the mouse mode to input mouse mode captured. It'll just make it so the mouse has disappeared on the screen, and I'll just center it to the middle of the window and make sure that it doesn't go outside the window. That way you can keep keep turning your head. We're going to use a get input event. We're going to set input direction to a vector 3 value, essentially resetting it every time we get input. Okay, so right here, we're just saying all we're essentially doing is these little handles right here move the player back and forth. These are the transform.basis, and you can move the node like this, which is way nice. When you have it rotated and I try to move him, you could see that he doesn't move in his rotated direction. So essentially what basis does is it rotates the things with him, and then he can actually move in those directions without rotations kind of screwing it up. We're going to normalize it, so if we're holding down 2 inputs, it won't be bigger than 1, and we're going to return input direction. Now this is just a function. This doesn't actually get input. Godot does have a built-in function for that, and so right here we're going to use it function underscore input events. If event is input event mouse motion. Essentially event basically is any type of input you can put in. It'll be anything. I mean anything, mouse movement, keyboard, controller, any type of input, touch input will go through. But we want to make sure that it's a certain type before we start messing with the event parameters, because it might not have those parameters if it returns a different type. If it's a mouse motion, we're going to rotate the Y of our character, essentially just like if you go to 3D scene, this is the Y. You're basically making him face the direction of negative event dot relative dot X multiplied by mouse sensitivity, and we're converting from degrees to radians, which is what you put in rotation Y. We're going to rotate the head on the X-axis to the negative event relative dot Y to multiplied by the mouse sensitivity, and we're going to convert that to radians. Essentially what we're doing here is with our head, we're moving along the X-axis, moving it up and down, our camera motion based on our mouse movement, and then we will move our character left and right based on the X movement. That's basically what those two do. Then we have to set our rotation.x, and we have to clamp it. This is for our head, and we want to make sure that it doesn't go past negative 90 or 90. Now this is because if we start rotating our camera and we move our mouse on the Y-axis, it'll just keep rotating around and around and around, and this will lock it, or 90, negative 90, and it can't go past those two positions. So this just handles our mouse movements and rotating our head towards that. In our physics process, we're going to add gravity to our velocity.y, and we're going to multiply that by delta. And then we're going to set a variable desired velocity. This is going to equal get input, which is this function up here, which essentially, does what it says, it returns our input, and we're going to multiply that by speed, because input is going to be equal vector 2, and we're going to multiply that by speed. And then we'll set our velocity.x equal to desired velocity, which is right here, .x, velocity.z, desired velocity.z. So this will basically handle our velocity how we want it. Then for jumping, we want to say if we press the jump button and we are on the floor, then set velocity.y plus equals jump speed. Sounds good. And then at the very bottom, we actually want to execute this velocity and move our player in that direction. And this function will just move our player in the direction so that we move him in, and he'll handle collisions automatically, which is way nice. We didn't put any networking code in it yet. We're going to get to that later once we get players instancing into the map. But right now, we just need to test to make sure our player works. So we're going to instance our player under our map scene so you can see him. And this ground is really blinding. So what we're going to do is we're just going to make a material. And I'm just going to set the albedo down to like a gray. There we go. That's better. And also, if you want to, you can go to your directional light and you can go to shadow. You enable shadow, make things look good. And we'll play our game. So we'll see if this works. And you can see I'm like inside my player's head and you can't really do anything, especially this UI menu is kind of screwed up because I can't select any of the UI. So I'm going to close this. I'm just going to hide my network setup at the start just so I can test this. But you can still see we're inside our player's head. So how do we fix this? Well, we just don't render our character when we are playing. But this is going to change when we are actually having multiple players in, because we want to render their characters, but we don't want to render our character. We still need to get a reference to our player's mesh so we can actually hide it. I mean, you could just hide the entire kinematic body, but I just like to hide the mesh. So what I'll do here is I'll just export another node path, onReady var model equals get node model as spatial. Now this is really important right here. If your model is not a spatial type node right here, and you're using a CSG mesh, make sure you have this as CSG mesh or else it won't work. So then we can go back in our player, set model back to our character model, press OK, and there we go. And now under our ready statement, I can just say model dot visible equals false. But you can see I can look around, I can move around, I can jump, and that's basically our FPS character. So that's everything we need for him. Looks like he's working just fine, so we can close the game, and that's everything there. We're gonna go back to our map. We're gonna toggle network setup back on so we can actually use that later, and we can delete our character because we know he works, and because when we set up the multiplayer game, we're actually gonna instance our players dynamically based on the players connecting. We don't want to have a character just sitting there already because that's gonna screw up with our view stuff. So the next thing on our list is actually to set up a new singleton. So what we're gonna do is we're gonna make a new script. I'm just gonna call the script global. I'm gonna press create, and then global global, what is this going to do? First thing that we're going to do, we're going to set up 2 signals, instance player and an ID that you have to put in for that signal, and toggle network setup with the toggle, which is going to be true or false. Where are we going to use these signals? Well, toggle network setup, essentially, if we send a signal and it's true, then basically we'll set the visibility to true. If it's false, we'll set the visibility to false for our network setup. This will let us change the network setup remotely. We don't have to be in the network setup node, and we don't have to have a reference to it. There's one more thing. It's entirely optional. Function underscore input event. If event is event key and scan code is key escape, quit the scene tree. So essentially just kill the game if we press escape. And then what we're going to do here, project settings, auto load. We're going to auto load global, and you can add that essentially so everything can access global, and essentially it will be loaded in the scene tree before everything else, which is way nice, which means that we can always check this scan code and always quit the game if we need to. So that's pretty cool, but we want to create players. We want to do some cool stuff. So let's go to our map. We're going to add a new script. We're going to create a variable for a player. We're just going to preload under our player scene. So make sure that this scene is valid, and as you can see, it's not valid on my end. So I'm going to re-update that to player.tscn. Make sure it matches the actual file, and you should be good. Under the ready function, we are actually going to have to need these 2 signals. These are not for debug purposes. They are very needed. Player connected and player disconnected, which will be connected from the scene tree. Remember, the scene tree was assigned a network peer, so that's why we're able to get these network peer connected and disconnected signals from it. Now we're going to say global.connect instance player to ourself underscore instance player. So essentially we grab this signal from global, which is our instance player, and we're able to connect it to ourself without essentially having to know where the node is in the scene tree, because global is already preloaded. And that means if we call instance player here or anywhere else, we can receive it in this same place on the map, which is way nice for instancing players outside of this script. We're going to check if getTree.networkPeer is not equal to null. Then we're going to emit signal toggle network setup, and we're going to set that to false. Now remember, we set up network setup here. We have it set up in the actual network setup, which we are going to later. That will essentially say, hey, network setup, we want you to basically turn yourself off. We don't want to see you anymore. So we're going to toggle it off using this signal in our map. So when the player connects, we're going to do our same debug stuff. Player has connected, and we're going to instance a player under this ID. Now we don't have this instance function set up yet, so let's actually set up this function. Let's set it up right here. Underscore instance player. It's going to take in an ID, and it's going to say player instance equals player.instance. We got a reference to that. We're going to set the network master of player instance to this ID. So what does this say? Well, this says that this player belongs to this computer ID. If I'm playing on my computer's ID is 1. Well, if my player's ID is 1, I know that player belongs to this computer. So if that player belongs to this computer, then I can handle input events and I can move my player, because I don't want to move other people's players. Because let's say my friend is player 2, right? Player ID 2 and I'm ID 1. ID 2 does not match my computer's ID 1. So that means that I can't move that player. Now, if you were able to move all the players, that's not really what you want. So this is why we have this ID system set up, is so we can actually handle inputs between players, and we can do other things using the whole network master system, which is way nice. We're going to set the name of our player to the ID, the string of the ID. This is also very important because when we're instancing nodes in our scene tree, on a networked multiplayer game, all of the nodes that are networked need to have the exact same names and need to be under the exact same parents on all of the machines. If they aren't, Godot's network multiplayer system crumbles and it doesn't work, and you get tons of weird errors, and you're like, I have no idea what's going on. Well, just make sure all your nodes are synced across all of the clients, and that's why we set our name to the string ID. Well, why does that matter? Because my player name is going to be the same across all clients, right? If I instance a player, it's going to be player, and that's the name of the player. Sure, yeah, that works for the first player. But let's say I instance a new player. Well, Godot has to fall back on its system for naming duplicates of nodes. We'll just say player at 1. So all the clients has duplicated that player, but let's say one client gets behind. Well, it's at all the other clients are player at 2, and this one client is at player at 1 for that one player. Well, that screws things up, and that will toss tons of errors everywhere for them, and they're out of sync. So essentially, to mitigate that problem, we set the name to the ID, and all the IDs are unique from each other, and we won't run into that issue. We're going to set player instance, our transform.origin, which is our location in 3D space, to a vector 3 0 15 0. So why did I choose this value? This is a really generic value, but let's show you. This right here, where this is at, this is 0 0. We want to instance our players about up here with the directional light, because we want them to fall onto the map. We don't want them to get stuck on each other. So I just quickly set up a stupid system that instances them in the air. They fall down and they can move around. And then we can add the child player instance. This is something else that's interesting that you might want to include in your other projects if you are working on a multiplayer project. I set the player's master before instancing as a child. If you don't don't do this and you try to check in the ready event if you're the network master or not, that won't work because you never set it up before you instances the child, because as soon as you add the child, the ready function gets declared. And so this ensures that we initialize the whole networking system for the player. That's why you just set that up there before that. All right, so that's great. We have players instancing when they connect, but what about when the player disconnects? Well, yeah, we want to destroy that player, right? Function underscore player disconnected. If we have the node that is our player, we string the ID, which is the name of our player, right? We have to find that node. Then we say get node, the string of our ID dot queue free. That essentially kills the player that has disconnected and instances the player that has connected. We're not done yet because we still need to set up our network setup script. So let's go here. If you remember, we actually set up in our map script right here, we emitted a signal somewhere here. Yeah, emit signal, toggle network setup. So in our network setup, we actually need to receive that signal. And so to do that, we actually need to connect it to ourselves. Under the ready event, global.connect toggle network setup to ourselves, just essentially allows us to listen in to that signal. And then we'll make that function below toggle network setup with the argument visible toggle, visible equals visible toggle. This doesn't really matter. Name could be anything. It's just what we essentially sent when we called the signal, which is the Boolean true or false. This should work. We should instance players. They should get instanced in as players join. So let's try this. You can see my mouse isn't locked yet because there is no player in the game, which is nice. I'm going to run it twice now. So I'm going to host. I'm going to join. You can see it only created the player after I joined, which is interesting. Let's look at our error right here. All right, so I made a mistake right here. We actually can't set our position before it's not in the scene tree. So just cut this line and just move it after we add the child. Now, it still wouldn't work because we have forgotten something in our network setup. We are only instancing a player when a player connects, right? That signal is only called once. Well, if I host my game, this signal still won't go off until someone joins my game, right? And when they join my game, it'll instance a player for them. That's why you didn't see me fall until a new player is created. Well, why did I see their view? They're the only camera in the scene tree, so it looks at their camera through their player. And there is no player for me. So we still need to make a player for yourself because right now we're only making players for everyone else. Well, that's simple enough. We just go in our network setup, and when the host button is pressed, we want to say global.emit signal instance player get tree.get network unique ID. Don't do this if you're doing a dedicated server because obviously you don't want a player for the server, because this is what happens when I press the host button. I want to create a player for myself. I am making a game that I want to host and play with my friends, right? Instead of the whole dedicated server approach. Get tree.get network unique ID essentially is just like the whole is network master. It just returns the ID of my entire scene tree of my ID, essentially who is me, the unique ID of myself. And that will make it so they can actually assign their network peer to the ID of the scene tree, which is what they want. Now, when you join the server, you still need a character for yourself. So what you want to do, global.emit signal, same thing, instance player, unique ID, right? We want to instance a player for ourselves when we join and host. Otherwise, we're only going to be instancing players for everyone else, which is what we don't want. So we can save that and we can run our game. I'm going to host and I'm in. You can see I immediately fell into the game and I'm going to press join. And then I fell into the game on the other side. Hey, don't forget, use the link in the description to download Core for free and start making your own game. So that's the end of this tutorial. In the next tutorial, we're actually going to be finishing all the networking and all the other stuff. And it's going to be finished. So that's going to be cool. So thanks for watching. You guys are awesome.